In May 2024, a company that made graphics cards for teenagers playing video games became the most valuable company on the planet. Worth more than Amazon, more than Google, more than every bank in Europe combined. But 30 years earlier, that same company nearly died, twice, before anyone had heard of it. This is the rise of Nvidia. February 1993. A Denny's diner in San Jose, California. Three engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, are sketching out a business plan on a napkin. They want to build a chip that does one thing better than anything else on the market: make graphics fast. Their bet was simple. The future of computing would be visual, and visual computing needed dedicated hardware. The gaming market was exploding. ID Software had just shipped Doom. Millions of teenagers were about to demand machines that could render 3D worlds in real time. Nvidia's first product, the NV1, launched in 1995. It flopped. The architecture was wrong, the timing was off, and Microsoft's new DirectX standard made it obsolete before it even shipped. They had 18 months of runway left. Jensen Huang gathered the team and told them the truth. Build something that works, or the company dies. What came out of that pressure was the Riva 128, released in 1997. It was fast, it was cheap, and it sold 1 million units in 4 months. Nvidia was alive, but just barely. 1999. Nvidia launched the GeForce 256 and called it the world's first GPU. That name, Graphics Processing Unit, was marketing, but it was also a declaration. This wasn't just a chip, it was a platform. The difference matters. A chip does a job, a platform becomes infrastructure. For the next 7 years, Nvidia printed money on gaming, but Jensen Huang was watching something else. Scientists at universities were starting to use GPUs for research, not games. Fluid dynamics simulations, weather modeling, protein folding, problems that required the same thing gaming did: massive parallel computation. A CPU processes tasks one at a time very fast. A GPU processes thousands of tasks simultaneously. For certain problems, especially ones involving matrices and numbers, a GPU was orders of magnitude more powerful. In 2006, Nvidia made the most important decision in its history. They released CUDA, Compute Unified Device Architecture, a programming platform that let anyone use an Nvidia GPU for general computation. Not just graphics, anything. It was a quiet launch, no fanfare. The gaming press ignored it. But in university basements and national labs, researchers started paying attention. 2012. A team at the University of Toronto enters an image recognition competition called ImageNet. Their model, AlexNet, destroys every competitor. Not by a small margin, by a margin so large that the entire field of computer science stops and takes notice. The secret ingredient? They trained AlexNet on 2 Nvidia GTX 580 GPUs. What followed was a gold rush. Every AI lab, every university, every tech company started buying Nvidia GPUs. Not because Nvidia planned it, because CUDA, that quiet little developer tool from 2006, meant Nvidia's hardware was the only hardware that could run modern AI workloads at scale. Google tried to build their own chips. So did Amazon. So did Meta. None of them could catch up fast enough. The CUDA ecosystem, the software, the libraries, the 6 years of researcher familiarity, was a moat that no one had seen being built. By 2017, Nvidia's data center revenue had overtaken its gaming revenue. The company that was born in a Denny's to make games look better was now the backbone of artificial intelligence. Then came November 2022. OpenAI released ChatGPT. Within 2 months, it was the fastest-growing product in history, and every company on the planet suddenly needed to build the same thing. There was one problem. Training large language models required thousands of Nvidia H100 GPUs, And there weren't enough. Wait lists stretched to 12 months. The price of a single H100 hit $40,000 on the gray market. Microsoft, Google, Meta, and Amazon were each spending billions on Nvidia hardware every quarter. Jensen Huang, the man who nearly ran out of money twice in the 1990s, became one of the most powerful people in technology. In June 2024, Nvidia's market cap crossed $3 trillion. The gaming chip company had accidentally built the infrastructure of the AI era. From a diner napkin in San Jose to the engine of artificial intelligence. But every rise has a flip side. And right now, every competitor on Earth is spending billions to build the chip that ends Nvidia's monopoly. That story is next.